All right, good morning. I'm planning to do in LeetCode contest 290 from yesterday. So here we go. Okay, open these guys up. Choop, 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 choop. Intersection of multiple arrays. All right, we can do these in Kotlin school. All right, 6:01 a.m. Okay, 2D integer array. Non-empty array of distinct positive integers. Return a list of integers that are present in each array of nums in ascending order. So just sort each of them and then return them. For array in a array dot sort turn. Oh wait, distinct. Okay, so they're in each one and then sort them. Okay, hold on. So need to read this and do it right. So okay, create a set of common values and sort that set. Right, that's the game plan. 2 a.m. 1 minute for game plan, and then let's do the implementation. Implementation. So it has to be in each of these. So on a set intersection, basically. So keep account of each unique value. Right, so that's what we can do. Use a counter for tracking the frequency, right, of each value. If frequency slash count is equal to the amount of k chunks, right, of arrays, then include that value in the answer, just sorted. And it goes mutable map of int to int. So it'll be our frequency count for, let's see, I want to call it a row, right? Row in A. For x in row, m sub x equals 1 plus m sub x. Oh, this operator 0 if it doesn't exist. For that. Right, so each of these are unique. All the values of nums of I are unique, so that works. I'm not going to count 2 3s here or anything. Okay, so then we'll do return m dot filter mutable map. Yes, let's do this. Var ans equals middle list of integers for x and count in m. If count is equal to var k equals a dot size k, and dot add x. Return and dot sorted dot to list. like that. 3 and 4. Taking a while. Okay. Oh, 6:06 a.m. Okay, cool. So that's like 4 minutes. 4 minutes for the implementation. AC. So that's cool. Is there a way that I can clean this up a little bit? Oops. So can I just filter M here and then return it as the answer? That's what I was originally going to try doing, right? Return M.filter. We have underscore CNT equals K dot map X dot sorted dot to list. Okay, let's see if that works. Something like that. Looks good. Taking a while. Okay, cool. Yeah, so this is kind of cool, right? Kind of cool and more concise than a for loop. Okay, so let's write this in. We can do. I don't know. It looks okay to me. Whatever. Let's do this in the other languages here real quick and then move on. All right. 6:08 a.m. JavaScript. All right, let's jam this out. K equals a.length. And for app, M will be our counter for row in A. Row in A. Oops, hold on. For let X of row. Then M dot set X 1 plus M dot get X for 0. And then return M dot filter count, where the count is equal to K dot map X dot sort be sorted in ascending order. There we go. Uh-oh. M dot filter equals K dot map. Okay, let's log what's in our map. That is not right. For let row, oops, of instead of in. That looks good. Okay. Bam, good. 6:10. 2 minutes. JavaScript. Here, let's post a new solution here real quick. Few solutions. Use a map M to count each row's values X. Each of the input matrix A, matrix A, right? Use a map M to count each input matrix A. This doesn't sound right? Whatever. Use a map M to count each value X of each row of the input matrix. Okay. Filter the map to, filter map to store. Need some coffee, obviously. Let's see, filter the map to return the sorted values which occur k times. Once per row. That works. Problem statement, that's good enough. Whatever, you can read the problem statement if that description is not good enough. JavaScript. Three. Rust. C++. Okay, let's jam on these, copy and paste them over, and then move on. It'd be cool to get to the fourth problem. Okay, oops. Go to Kotlin. Where's Kotlin? There's Kotlin. This guy, stick him here. Kotlin, JavaScript. Let's do Python 3 next. Rust and then C++. Okay. 6:13 a.m. Okay, K equals length A. And then for row in A, for X in row. Wonder if we can create a counter of that array. Let's see this. M equals counter A. I don't know if this will work or not. I don't know. Let's see. Okay, that doesn't work. That makes things easier. M equals, let's do a default dict. Integers, then for row in A, for, oops. X in row, M of X equals 1. And then return M dot items sorted this guy M dot items for X. Let's see. Count in this guy if count equals K. Then map it to just the first one. Map lambda comma underscore this guy there. Map it to X. Okay, I'll do this guy. I think. No. Map. Oh, can we do this X for X comma count in, and then just sort this thing? I think that works, right? Yeah. Okay, cool. All right, 6:13, 6:15. 2 minutes. Okay, stick this here. Boom. Okay, rest. Okay, type vi equals vec I32. Type VVI is vec VI. All right, so VVI, oops, be VI. This will be VI. Okay, and then for row in A, for X in row, oops, let mute m equals use SD collections hash map. Hash map will be our counter. Hash map new m dot entry x dot or insert 0 plus equals 1. All right, and then map the m into all the values k equals a dot length. Turn m dot, I think there's a filter, x count, let's see, count equals k dot map x dot sorted, or to collect it and sort it, collect dot sorted. I don't know. Rest might take a little bit of trial and error here. Filter doesn't exist for the hash map. Oh, m dot iter. Closure expects to take one argument. Oh, inside of a grouping. Taking a while. I don't know if that's a good sign or not. Oh, okay. Kind of compare this thing with the U size. No implementation for that thing. Partial equal. Oh, it's strange. What the heck? Does it dereference this thing? That's I32. No implementation. Reference equals that thing. The reference key? Type annotations needed. Cannot infer the type. Collect I32s and sort them? I have I32 cannot be built to iterate over ampersand I32. Method not found in I32. Let's come back to this one. Whatever, this is taking a while. Let's jam out on C++ and move on. 6:20 a.m. Vector of integers, PBI, vector, PBI, PBI, and A. Using map, it's unordered map. Our counter. Map M for auto row and A for auto X and row. Specs. Return. Oh wait, we want to filter M and then transform it. We can copy it into the answer. That would work, right? That ends. Actually, let's do this using set equals set. That'll be our answer. Set turn and up again. And so turn the set into a vector at the very end. And then for auto x count in M, if count is equal to k, then and insert x. Okay, that should work. Okay, it's not defined. Auto k equals a dot size. Looks good. Okay. To do implement me. Well, actually, you know what? I can do this one the longhand and then fix it up later on, right? So let's do let mute ands equals vec. Return the answer in the end. And then for x count in M. Iter. If count equals k. And dot push x. Sorted. I32 and I32. Sorted. So we gotta sort it and then return it. And dot sort. Return ands. Expected vector of I32. Expected I32 found. Okay, that works. A little verbose, but whatever. I guess to do is like clean me up. That's fine, whatever. Looks good. All right, this Kotlin, JavaScript, Python 3, Rust, C++. Okay. One's done. How much more time do we have? That one took about 23 minutes. Okay, 1 hour, 7 minutes left. Q1 took about 23 minutes. So we have 1 hour, 7 minutes remaining in the contest for Q2 to begin. Okay, we'll do this in Kotlin first. Also bigger motion, give the circle lattice. And the circle are 1, 2, 2, 1, 3, 2, 2, 2, 3. Okay, that makes sense. Those are on the edge. Other points is this 1, 1. Okay, those do not exist on the circumference. Okay. There are exactly 16 lattice points, which are present inside at least one circle. One, two, one, two, three, 4, 1, 2, 3, 4. Okay, so there's 4 sets of 4. Is it or? 0, 2. Some of them. Okay, it doesn't give all of them. I suppose we would only need to check 1/4 of it. Why is 2, 2 a lattice point? Lattice point is a point with integer coordinates. Points that lie on the circumference of a circle are also considered to be inside of it. Three, 2. So there's actually these points in here. 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. A hard time understanding this question. The radius is less than the minimum of x and y. So it's basically, this part here says that it stays on the top right quadrant. So that does make things easier. There's not that many circles, so it looks like we can do like a brute force solution. For each circle, keep track of the set. Keep track of the set of points within it. If each circle would have 4 points, or no, 5 points. Each circle has a minimum of 5 points, right? Each circle has a minimum of 5 points. Top, down, left, right, in the middle. It's a small circle, circumference 1. So if you have circumference 2, or radius 2, then it's 1, 2, 3, 4, 5. Wait, 1, 2, 3, 4. Wait, 1. How do I want to count this? Is there a formula? No, because these things can overlap, so I don't want to count it that way. I suppose brute force solution, brute force solution looks feasible. We can iterate through the, I guess, from the top left to bottom right of each circle to count the what do they call these things? Lattice points via a set, right? Because this is important because circles can overlap, and we want to count each lattice point exactly once. See, each circle has a minimum of 5 points. The smallest circle with radius 1 with radius 2 we have, how many points are there? There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Does that sound right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And there's 14, 15, 16. 13 here. There's 5 there. 13 points. Is there a formula? And does that matter? Right? Maybe not. 13 points, radius 2. What would he have with radius 3? Right, it's 12 plus 1, it's 4 plus 1. Right? 1 middle plus 4 points. 1 middle plus 12 points. Does it matter? What? I guess how many points exist with radius, oops, radius 3, 4, 5. And in general, I don't think so. I don't think so. Because circles can overlap. We need to manually check those via set, I think, right? So, okay, let's just start. Let's see, hour and 7 minutes is when I started. 7, 4, okay, so it's about 11 minutes, right? Oops, 11 minutes for game plan. Okay, and let's start the implementation. All right, so implementation start at 6:35 a.m. Okay, array of circles. Okay, so for X, Y versus UI, does that matter? I and J are. I can be rows or columns, right? It doesn't matter as long as I'm consistent. Radius. Oops. Those values in the array. So if we, the center is here, the top left will be somewhere up here. I guess the radius is 2, we'd start here. And this is not within the Euclidean distance. So we need a Euclidean distance function to see if it's inside or outside the array. or the circle, right? Our dist equals I int j int u int v int. Okay, so the absolute difference in the x, absolute difference in the y. Square those, add them up, and take the square root. All right. Math dot square root math dot abs I minus u squared, right? Let's do this. Just turn it into a function. It's a little bit too verbose for a lambda. So we'll turn a double. All right, so let's do our x equals math dot abs I minus u, our y equals math dot abs j minus v. And then we want to return math dot square root of x times x plus y times y. Okay. X is our distance. Center to whatever it is. Top left will be I minus R. J minus R. Bottom right, I plus R. J plus R. dr is our distance. For u in the range inclusive I minus R to I plus R. For v in J minus R to J plus R inclusive. So this is our distance from I, J to U, V. If D is less than the radius, less than or equal to the radius, then we'll increment the count. Count equals 0, return the count in the end. Let's count. Something like that. Right, so for each circle, center point I, J, and radius R, and the input array A, goes to the top left, I minus R, all the way to the bottom right, I plus R, J minus R, J plus R, that looks good. Okay, yeah, something like that. Okay, so 6:35 to 6:40, about 5 minutes. Okay, let's see what happens. Uh-oh, doubles expected. Okay, let's do this. Two, double, two, double. All right. Come on, lucky number 5. Yay. Okay. And then do the other one. It should be 16. Ooh, this is not right because I didn't do the set, right? Okay, this is incorrect implementation. Incorrect implementation. I forgot to use a set, so I'm over counting overlapping lattice points. When 2 circles overlap, the example 2, right? Okay, so that's right. But we can make it right pretty easily. Our scene equals mutable set of integers. All right, we'll turn scene.size. Okay, and then so UV is what I'd want to add, right? So scene.add u.v. Okie dokie. Oh, so, oops, it is want to be a string. Okay. 5 and 16 looks good. Yay. Okay, 642 is accepted. Let me see, 6:42 a.m. What time did I start? 11 minutes before this, 6:22. About 6:22, right? 6:22 to 6:42 is about 20 minutes. Let's do this, shorten it up a little bit. That's our distance. And then we can get rid of all this stuff. Okay, that looks good. Yay, okay. So see how much time we have left in the contest, 48 minutes. Okay, so let's do this real quick in the other languages and then move on. About halfway through the contest and we've done 2, so that's cool. Solutions. So use a set. Okay, sorry. Formulate the answer. Well, I guess I use a set of scene coordinates. I guess I could return the cardinality of the set of scene coordinates. I guess, yeah, naive brute force solutions, which consider all possible points within circle. Yeah, return the cardinality of the set of scene coordinates within each circle, right? Circle. I guess brute. Whatever. It's pretty obvious it's brute force, but whatever. Return the cardinality of the set of scene coordinates within each circle. Well, that works. JavaScript. Python 3. Rust. C++. Okie dokie. So we did Kotlin first. Boom. Stick this guy here. Okay, let's do this. JavaScript. 6:46 a.m. Okay, let's do this. Scene. It's a new set. Return scene to size. For let's see, let this equals ij u b. return, let's see, let x equals math.abs I minus u, y equal math.abs j minus v, return math.square root of x times x plus y times y for ijr of a, or let u in the range u equal I minus r, u is less than or equal I plus r, plus u, or let v equals j minus r, v is less than or equal to j plus r plus v, if dist ij u v is less than or equal to r, scene that add u shine v. Already looks good. 6:46, 6:47. Got 1 minute. For implementation. AC. Implementation. All right, that's cool. Let's move on. Boom, boom, bam. Okay. Do Python 3 next. So scene. Scene equals set. Return length of what's been seen in the end. These are distance, def distance, I, j, u, v, x equals absolute value of I minus u, y equals absolute value of j minus v, return square root of x times x plus y times, right, x squared, y squared. Okay, so for I, j, r, and a, for u in the range I minus r to I plus r inclusive, for v in the range j minus r to j plus r inclusive, if the distance from I, j to u, v is less than or equal to r, then scene.add format string u, v. Oops, v, v. Okay, that looks good. Here we go, good. Taking a while. Taking a real long while. Okay, let's go TLE for a second there. Okay, that's good. Okay, rest in C++, and then move on to question 3. All right, type VI goes back I32. Type VI goes back VI. Okay, so here's our VI. VI. Use SCT collections hash set. Let mute scene equals hash set new. Return scene dot length in the end as 932. That's use size. Okay. And for IJR and A, I should create the distance function fn dist I32J, I32 U, I32V, I32, and that will return a floating point value F32. Let x equals use std math. Oh wait, absolute value is actually Yeah, it's I minus u dot abs. Let y equals as f32, j minus v dot abs as f32. I think that works, right? Return square root. Hold on. Press square root. How do we get this thing? You didn't have square root? What is this? Square root is a function you can invoke on S32. Interesting. Okay, that's right. Okay, so return x times x plus y times y dot sqrt, right? Something like that. Okay, and then so for u in the range I minus r to I plus r inclusive, for v in the range j minus r to j plus r inclusive, if the distance I j to u v is less than or equal to r, then seeing that add format the string uv, something like that. This expression is option vec. What? Expected struct. Oh, it's a vector of vectors. Okay, so for row in this, I can't destructure the vector. All right, okay, so let ijr equal rows of 0, rows of 1, rows of 2, something like that. Use return value arrow expected f32 found I32 r as f32. Method not found. Oh, seen insert. Uh-oh. 519. I minus r to I plus r, j minus r, j plus r inclusive. Oops. Y times y. X times x plus y times y. Okay, it looks good. Yay. Okay. And then C++, move on. Okay. Vector vectors. VI, and using set equals numbered set strings. It's a set of what's been seen. Set a scene. Return the cardinality of what's been seen. Answer for auto row and A. Auto I J R equals tie rows. 0 row. Very verbose to destructure in both C++ and Rust. Auto dist equals anything here. I, auto j, auto u, auto v. Return the square root of x times x plus y times y. Auto x equals absolute value of I minus u. Y equals absolute value j minus b. Okay, and then for auto u is equal to I minus r. U is less than or equal to I plus r plus u. For auto v is j minus r. V is less than or equal to j plus r plus v. If the distance from I, j to u, v is less than or equal to r, then scene.insert key uv, key auto u auto v, string stream. That's so let's input u, oops, comma, v, return as a string representation. Oops, that thing, okay. And that looks good. Taking a while. Okay. Oh no, it did TLE. Oh dang. Okay, whatever. You know, the online judge is really strict on C++. Poor C++. You do the same exact thing, you end up with TLE. It's probably because this key, I would suppose. Maybe there's a better way of doing it than strings, but whatever. This is good enough. Right, that's cool. Return the cardinality of the set of scene coordinates within each circle. All right, that works. Okay, cool. That's good. Did that. Okay, so 32 minutes left on this guy. Okay, about 32 minutes remaining in the contest, and I need some more coffee. Okay, be right back. Okie dokie. All right, yeah, so it doesn't look like I can get to the fourth question, but whatever, I can do the third one probably in 30 minutes here. I got about 30 minutes left. Okay. Okay, let's do this. It is 7:01 a.m. And we're coming up with how many minutes for the game plan here? Count the number of rectangles containing each point. Oh, okay. Like the circles, but rectangles this time. Okay, so it looks like Triosky dolls or okay, so there's 50,000 of these things, and X is pretty big, but Y is fairly small. Wonder if we can sort the input, pre-process the input by sorting it. It seems to make sense to form linear scans. How many points are there? All the points are unique. Wait, the points dot length is 2? Rectangles. Wait, no. Yeah, points dot length. There's a whole bunch. Okay, so there's a whole bunch of rectangles, right? There's 50,000 rectangles. There's 50,000 points. So basically, a naive solution will TLE, right? So naive quadratic runtime solutions are expected to result in TLE, since 50,000 times 50,000 ends up being, what is that, 250 million? 250 million. Right, and we only have like 1 or 2 million operations at best, about, right? So, okay, we can start with a naive solution maybe and then try to optimize it. It's usually a good way to just start jumping into it without getting stuck in the analysis paralysis. Edges are in. Oh, yeah, you know what? We can sort it and then do a binary search. That's what I think now. Yeah, sort and binary search. Yeah, that makes sense. Okay, so I think it makes sense to avoid TLE by pre-processing, right? Pre-processing the input by sorting it so that we can perform binary search upon it for a big O of n times log n runtime algorithm, right? Runtime algorithm, algorithm, which is expected for AC. Okay, so let's do the implementation of the game plan 7:05. 7:05 a.m. It's about 4 minutes for the game plan. Okay, and then let's do the implementation. 7:06 a.m. Implementation for brute force solution, right? Well, let's just do this rectangles to R and P. How about rectangles and points? matrix equals array of int array. A little bit less verbose, right? I think this works, right? Matrix, return int array of, this is supposed to be 2, 1, 2, 1. First example. Okay. So let's sort the rectangles. Let's do this. This is array, and we'll just call this guy query. About queries. It just points is okay, right? Points. Each point in points. Okay, so we can sort A with a custom comparator. A is int array. B is int array. And each of these are of size 2. Really nice if they were pairs, so I could destructure them easier. Let's sort these things. Sort them by X because X is huge. And then by Y? Yeah, X first and then by Y. That makes sense, right? Okay, so if A sub 0 dot compare to B sub 0, or actually, if A sub 0 is equal to, then we turn to this. If A equal to, or the x's are equal, then we'll do A sub 1 dot compare to B sub 1. Otherwise, A sub 0 dot compare to B sub 0. Oops, B sub 0. For row in A, frontline row dot join to string. Okay, then return int array of 2, 1. Println each of those. Uh-oh. This is not like your type inference failed. Where? What? Comparator. Comparator int array, but int was expected? For type is comparator int array. Sort int array. Array of int arrays. What the heck? So is it sort with? Sort with comparator? Okay, it's sort with. Oh, jeez. Okay, so sorted by X and then by Y. That looks right. Okay. For IJ in query or points. our ands equals mutable list of integers. Answer as a 2int array. Okay. So k equals 0. While k is less than a dot size, and a sub k sub 0 is less than or equal to, oops, yeah, right, I is within a sub k sub 0, and j is in a sub k sub 1. It's k, and then how many points that one is in is k, right? So and that add k, and I think that's all there is to it, right? Uh-oh, 0 and 0. 2, 1. Oh, it should be inside of it. The up from the smaller to the bigger, but the bigger to the smaller. Size -1. 0 is less than or equal to k. And those, and let's do this. N equals a dot size. So it's n -1, and then we're going to add n minus k. What k is in? So k -1, k -1, k -1, n minus k. So if it's not in any of those, then k will equal to n. It'll be 0. Okay. Yeah, so big to small. 2, 1 looks right. Okay, and then it should be 2, 1. It should be 1, 3. 2, 1, 1, 3. Okay. So this is expected to TLE. Wrong answer. Uh-oh. Okay, so this is a corner case where maybe X and Y don't match up. This is the wrong answer because I missed considering both x-axis and y-axis. I'm pretty sure. And I'm pretty sure about. Okay, so 7:06 to 7:15. 9 minutes for incorrect implementation, but failure path towards success, I suppose. Okay. Let's print this out after we sort it. Print for row in A, println, join to string. Okay. See how these are sorted, how this works out. So these are my sorted points. And these are my queries. And this thing. output, and that's what's expected. So I'm not counting enough. 10, 3, it's supposed to just be 1. 8, 10 is none. 2, 3 is supposed to be 4 of them. And I'm only counting 1. 2, 3. Oh. Yeah, so 2, 3 doesn't count because of this guy. So maybe I need to sort the points by both X and Y. You sort it by X and then sort it by Y. I don't know, it's kind of weird. Okay, but anyhow, let's do this then. Let's just go through all the points. All right, if we're gonna do brute force, we're gonna do brute force. Okay. For UV, for candidate in the array, UV equals here, candidates of 0, candidates of 1. If I is less than or equal to U and J is less than or equal to B, then we'll increment K. Okay, this should be a brute force solution, which should TLE now, I think. Right, you can't short circuit it the way I was previously. Okay, TLE, all right. TLE as expected. Okay, 7:19. 7:19 a.m. Okay. Okay, so time to continue working on the pre-processing plus binary search. So in this use case, this is the bottleneck. Bottleneck for short circuiting the search space based upon Y, right? Based upon Y axis. The X axis is cool. The Y axis for the point 2, 3. Wonder if we can. It seems like a divide and conquer approach will work, right? We want to divide all the ones that are not applicable. I'm going to filter them out based on that. Do a search for both X and Y axes. binary search in the X direction as well as the binary search in the Y direction. But the X and Y are sorted differently. All right, so all those X's within all those Y's. Oops. Yeah, so what if I had points in two sorted lists, right? One sorted list of, or the rectangles. Does it make sense to sort the rectangles? Maybe it makes sense to sort the points. We sort the points. Could we reuse previous points? Minimize the points, maybe. If we query for the same exact point, you might as well not do the calculation over again. And that's pretty obvious, right? Is points unique? Oh, points are unique. Okay, rectangles are unique. Points are unique. Okay. I guess if a point is smaller than another point, then it's within the same, right? It's down to the left of the current one, and right, the previous one is down to the left of the current one. Then we can reuse all the previous ones, and then just check the delta between the previous and the current to see if there's other ones we can add on top of it, like a dynamic programming. I think that might work, right? Yeah. So, what if we sort both rectangles and points? Then we can formulate current from previous. Or I don't know if that's going to be too complicated or not, because it can be short-circuited by the constraint of X and Y. Sort them both. I think I might have to write this down on a piece of paper, right, and kind of really think about this. Maybe upsolve this one later. I have basically two variables, right? Variables x-axis and y-axis. I want to find the intersection. The intersection. I guess I want to find like all the rectangles, which each point exists within the overlap. Right, but the challenge is that the rectangles overlap. In potentially conflicting ways, right? Which make a nice sort. Right, it's an incomplete solution. Incomplete solution. It doesn't work all the time due to specific bottlenecks. this guy. Here's a bottleneck for short circuiting the search space for 2, 3. Y-axis is 1. We still have more exits, okay. Okay, we have 4 minutes left, so yeah, we'll certainly come back and upsolve this one. It seems interesting. It seems like a pretty cool question. Maybe this has something to do with it, the Y being 100. Maybe it makes sense to filter on those Y's first. The X is a billion. Right, maybe sort by Y first. There's only 100 of those things. Sort first by Y, then by X, so we can and this is key, right? I do believe this is key. Right, this guy, key point, key data, right, this guy. This, I think, it makes sense to, right, to avoid TLA by first filtering upon Y-axis, since there's only 100 values, right? 1 to 100 inclusive. Then after we filter out hopefully a whole bunch of X's based on the limited filter criteria of Y, right? Then filter X-axis. As next step, something like that, right? Something like that, right? Yeah, something like that. Okay, anyhow, 2 minutes left. I'm gonna call it a day. Catch you next time.